Let's look now at a heat transaction that doesn't result in a temperature change, but results in a phase change. It's called latent heat, and it occurs either when we're melting or freezing something, or when that thing is boiling or evaporating or condensing. Only two variables in this equation: how much of it you have, the mass, times the latent heat. And this is different depending on whether you're in this liquid-solid transaction or this liquid-gas situation. So L is the latent heat, either of fusion or vaporization. The latent heat of fusion, this is water, the latent heat of fusion of water is 144 BTUs per pound. And the latent heat of vaporization of water is 970 BTUs per pound. So already from this you can see that going from a liquid to a gas or a gas to a liquid involves a lot more heat per pound than the melting freezing situation. So the equation takes two forms depending on which situation you're in. You have mass in both of them. You just have a different value for the latent heat of fusion than value of latent heat of vaporization. All you have to do is write it out and do the math. And this is a situation where you want to know how much heat does it take to boil something? How much heat do I gain back to the environment when I condense something? It's important. Let's see how it works out. Substituting the values in then. For the melting freezing situation, it's either positive or negative depending on which one of these you're doing, but the amount of heat is the same. You're talking about 5 pounds times 144 BTUs per pound. First cancel the units. You're ending with BTUs. That's what you want because you're looking for a quantity of heat. The pounds cancel. You get 720 BTUs to melt 5 pounds of water. Let's look then at this situation. We have again 5 pounds of water. This time we have the latent heat of vaporization, or 970 BTUs per pound. Again, the pounds cancel. We get 4,850 BTUs, which you can see is a bigger number than this 720 because the latent heat of vaporization is greater than the latent heat of fusion.